Okay, let's get started. So in the last session, what was the topic that we discussed? We discussed the concepts related to Terraform and how we can create the resources and how we can provide the authentication to access the AWS and how we can create a VPC inside the AWS. So with the help of Terraform, this is the concept that we have discussed in the last session. In this session, let us discuss about the concepts related to the basics of Terraform, where and how we are going to create and how we are going to variabilize the configuration. And then we will be discussing about what is meant by uh, Terraform and variable files, variables.tf files, and tf var files. Like that, we will be having so many different types of files that are available. We will discuss about that. Okay. So now, uh, just a second. Hmm. Okay. So this is the directory on which we are creating the Terraform configuration. Yesterday also we have worked with this. And now let us see what we have discussed. So this is the main.tf. In main.tf, we are having the provider AWS, and then we have created the resources. And if you see in the Terraform state file, we have destroyed everything. So I just destroyed everything. So this is the backup file, which is not required right now. So I'm going to delete the backup file also, and I will delete the state file also. So right now we are having main.tf. You can have in a single file. You can create the VPC inside the main.tf itself, or else what I will do here is I will change it to provider.tf. So this is the file which I have created, and inside the provider.tf we are setting the provider. Okay, so the AWS provider is this. And if you want to specify the Terraform version, okay, if you want to specify the Terraform version also, you can specify that Terraform provider AWS. Here you can see I want to use a specific version of Terraform. Then how I can use that? So here you can see required provider AWS and version. Version is 6.0 in the sense this is greater than or equal to 6.0. It will be varying between 6.1, 6.2 like that. And not only that, here you can specify the Terraform version also. Okay, so uh, what you can do over here is required version will be there. Terraform required version. If you want to use a specific version of Terraform, then you can configure like this. Okay, Terraform required version, and you have to specify the version ID. So like this, greater than or equal to 1.7.5 or else no less than or equal to 1.9.5. Like that, you can specify the required Terraform version. So now, for example, I will give like this. Terraform version. Okay. So provider is AWS and Terraform version will be like this. Okay, good. So version is greater than or equal to 1.7.5 or else right now what is the Terraform version? It is 1.13.5 if I am not wrong. Terraform.io install, then 1.14.0 is the latest to Terraform version, but if you want to specify like 1.12, okay, so let me check. 1.12 is there. I mean, if you want to specify any specific version of Terraform, you have to specify in this manner. 1.12.0, for example, greater than 1.12.0 and less than or equal to 1.13.5. Okay. So this is the Terraform version which we have to use. You can specify in this fashion. Okay, so if you whatever the version of Terraform that you want, you can specify like this. Or else if you want to specify the provider AWS version also, you can specify the AWS version. So how you can specify the AWS version? You have to specify in this fashion. So this is the one. So required providers, required underscore providers, AWS, and resources is equal to Hashik of AWS greater than or equal to 6.0. If you don't specify the version, no, then what it is going to do here is it is going to take the latest version. Okay, so now if you see here, cd colon terraform init. So, provider.tf Terraform, the configuration does not support version 1.13.5 to proceed. Choose supported version. 1.13.5 is not there. Is there, but let me check one point. Or else I will make it as 1 point greater than or equal to 1.12.0. Let me check like this. Terraform init. Then it has been initialized that particular Terraform. Okay, with the version 1.12.0 and the AWS version is 1.6.21. So if you want to specify a specific AWS version also, you can specify it like this. Depending on the requirement. Okay, so that is how you can specify the versions inside the Terraform. Like certain versions will have the updated plugins, certain versions will not have. And your companies might be using the older version of AWS or else older version of Terraform. You don't want to use the latest version. Then how we have to specify that version inside the inside this particular document is in this fashion. And here you can specify the required providers also. Required provider is equal to, you can specify in this fashion. Okay, required version and required provider. So only this particular provider will be configured. If you want to equal to 6.0, you can specify in this fashion also. Equal to 6.0. Okay, and then I will initiate that. Could not retrieve the list of available versions of provider. Log provided Terraform 6.21.0 does not match the configuration constant. 6.0.0 must use the Terraform init hyphen upgrade to allow the selection of new versions. So let me check out the Terraform init hyphen upgrade. See that it is installing 1.6.0. Previously, it is installing version 1.6.21, which means it is downloading the plugins related to that 6.21.0 in the previous. Why? Because we did not specify any AWS version. But when we specify this AWS version, see here we have specified what is the AWS version 1.6.0.0. So it is downloading the plugins related to version 6.0.0. That totally depends on the what are the new upgrades. So if it is a latest update, then it will have all the updates or else all the upgraded resources of AWS. It will have all the plugins related to the latest upgraded resources. But when we provide the previous version, then it will have the plugins related to the old resources. So that is the main difference. So depending on your requirement, again, coming back to the point, how we have to specify the version, what is the version that I have to specify, that totally depends on your requirement. Okay, your requirement in the sense company requirement, what is company requesting, whether we need to have the specific version or else we can have the default version. Depending on that, you can specify that. Okay. So I will be going with the default version only, but for your understanding, I'm saying you this configuration. I'm removing this, and again I will go for Terraform init. Okay, I will go with the hyphen upgrade. Okay, this time it is going for version 6.22.0. That's fine. So that is the concept of your Terraform. just versioning of your Terraform, how you have to specify the Terraform version and the AWS version. Why? Because we are using the AWS AWS cloud. I'm specifying the AWS version. If you are using the Azure cloud, you have to specify the Azure version like that. All right. Next one is then what we have to do once we have initialized this. I want to create a vpc.tf. Okay. Before I go into that, is everything clear for you? What we have done right now? What is meant by versioning and how we are going to modify the version? Any questions here? Do you understand what is a versioning, you guys? Pranti,
Yeah, no.
Nageshwar, Vikram, Vinay. Okay. So let us create a VPC over here. So in general, in AWS, VPC is a network block where we can create multiple resources. So resource AWS underscore VPC, and the name of the VPC will be demo hyphen VPC, or else you can give okay, demo hyphen VPC, and then CIDR block is equal to 10.90.0.0/16. And then what I can do here is enable DNS host names is equal to true, and then tags. What is the name of that particular VPC? So name is equal to, I will go with prod hyphen VPC. Like that, I am going to provide the VPC details. When I provide the VPC details, and now the VPC is getting created. So this is how you have to write the configuration. So if you are creating any new resources, then the Terraform language in HCL language, it will be starting from the resources, and then which type of resources, either it might be VPC, AWS underscore type of resources, type of resource. If it is a VPC, then that will be AWS underscore VPC. If it is subnet, AWS underscore subnet. If it is internet gateway, AWS underscore internet underscore gateway, like that. And then here you have to specify the name of the resource that should be understandable by Terraform. Okay. So this should be Terraform understandable name. So this is how you have to write the, and then inside this here you have to specify the options. So like if we are creating a VPC, then we need to provide CIDR block. If we are specifying internet gateway, we have to specify the VPC ID, to which VPC we have to create the internet gateway and all things. So this is the common syntax. Okay, so resource, AWS resource type, and then name of the resource. So the same we have specified over here. If you see resource, AWS underscore VPC, and then the name of the VPC, CIDR block, and DNS hostname. And then if you want to create any subnet inside this particular VPC, if you want to create a subnet, then how you can specify that? If you know AWS, that is fine. If you don't know AWS, let me explain you what is a VPC. VPC is a network range, okay, very big network range. And inside this VPC, what we are going to do here is we are going to create some subnets. Directly, we are not going to create the EC2 instances inside the VPC. So this is a subnet, which is a little bit or else a sub network of this very large network. Simply, if I have to tell you in a layman terms, there is a very big city is there, like Hyderabad, Bangalore, very huge city is there. To manage the entire city, a single police station or a single administration block is not sufficient. So for that, what we are going to do here is we are going to divide that city into subdivisions. Okay, subdivisions, and for each subdivision there will be an administrative block and there will be a police station. So here also what we are going to do is when we are specifying the VPC, VPC is very huge. To manage that VPC, it is a little bit difficult. So to overcome this problem, what we are going to do here is we are going to divide that network into small subnets. So like here, we are going to create the subnets. Okay. Like this, we will be creating the subnets. So where we have created the subnets, subnets are created inside the VPC. So this is my VPC which we have created, that is prod-VPC, and this is my subnet which I am going to create, that is prod-subnet-1 and prod subnet 2 and prod subnet 3. Like that we can create the subnets. Let us create that resource. What is the resource that I want to create? AWS underscore subnet. This is the resource which I want to create, and the subnet name is demo hyphen subnet hyphen 1. And in which VPC we want to create this? VPC ID is equal to AWS VPC demo VPC dot ID. Okay. Demo inside this VPC, I want to create the subnet. Okay. And the next one is, what is the CIDR block? CIDR block is equal to 10.90.1.0/24. And then what we can do, availability zones. So availability zone is equal to US hyphen east hyphen 1. US hyphen east hyphen 1. This is the availability zone. US hyphen east hyphen 1A. This is the availability zone. And then what else we have to specify? Map public IP on launch is equal to true. And finally, tags is equal to name tag is equal to what I can do, prod hyphen subnet hyphen 1. So prod subnet 1, this is the name of the subnet. With this, we have created a subnet, and that we can create it. If you want to create one more subnet, you can use the same block, and this is the subnet 2, and the CIDR block is 10.90.2.0, and I want to create in US East 1B, and the subnet name is prod subnet 2. Like that, you can configure the second subnet also. So now we have the VPC and we are having the subnets. Let us see whether it is going to be created or not. So Terraform FMT and Terraform validate. I already said you what is meant by validating. Validating means checking out if there are any errors or not. So configuration is valid. There are no errors. Terraform plan. Planning means dry run, or else it's like what are the resources that are going to be created. Here you can see, with the help of the code, whatever we have written, we are able to create a VPC, and then we are able to create the subnet 1 and subnet 2. Two subnets are getting created. And Terraform apply. Before I apply this, I just need, okay, no problem. Terraform apply. Yes, let me check out whether this is having the, yeah. So what it is saying, user 1 is not authorized to perform. So we have the credentials. So where are the credentials? So here you can see provider.tf, we don't specify any sort of credentials over here. User credentials are not there. In the last session itself, I have said you that. So either we can create the credentials inside this file, or else we can put the credentials in the environmental variables. Either we can put the credentials in the environmental variables, which are located in the system properties. Environmental variables are also not there. And the last and final method is inside the .aws directory. Here you are having the credentials. So there you go. So the user, whoever is having, user 1 is not having the permissions. Let me go back and check out in the AWS user 1 and add permissions. attach the policies. I will provide the administrator access, next, and add permissions. So once we have added the permissions, now if you try to create if you try to go for Terraform apply, then it is going to create the resources inside the AWS environment. Did anyone knows about, anyone don't know about AWS, or else anyone is new to AWS? Can you please let me know about that? Why? Because we will be dealing only with the AWS environment. So if you see here, the VPC is going to be created. So what is the VPC name? The VPC is hmm, prod-VPC, which has been created with the side at 10.90.0.0/16. Here you can see it is going to say you that. So VPCs are created, and inside the VPC, two subnets are getting created, subnet 1 and subnet 2. So if you want to check out that, so where you can check out what are the resources that are created, you can check the resources in the Terraform state file. Here you can see. So this is the state file, the version number and the serial number. And here you can see VPC got created. AWS underscore VPC, demo VPC, and this is the VPC ID, and this is the CIDR block. Okay. Once the VPC is created, then what is happening? It is creating the subnet 1 and subnet 2. One thing you have to understand here is we have the internal dependency. What is the internal dependency? In the sense, until VPC is created, the subnets are not going to be created. Why? Because subnet should be created inside the VPC. So until the VPC is created, the subnets are not going to be created. So this is called as internal dependency. So the resources are a specific resource is depending on the another resource creation. So that is called as dependency. So now here you can see the VPC is created. After VPC is creating or created, then it will have a VPC ID. Here you can see after creating the VPC, we will have the VPC ID. Okay. So now in the subnet, what is the code that I have provided? If a subnet has to be created, in which VPC it has to be created? It has to create inside the AWS underscore VPC dot demo VPC dot ID. So it will go to the state file and it will check AWS underscore VPC demo VPC dot ID. So here we have the VPC ID. So it is going to create, it will take that ID and it will create the subnets inside that specific VPC. So now if you go back here and check out in the subnets, there you go, prod subnet 1 and prod subnet 2. These two are created in the same VPC. So like that, what is going to happen? Dependencies will be there. And if you want to create an internet gateway, so how you can create that? Sources AWS underscore internet gateway, and this is my demo hyphen IGW. So demo internet gateway. Now, what is an internet gateway? Internet gateway is an entry and exit point. Whatever the data that has to come into the instances inside this VPC, and whatever the data that has to go outside of the VPC to the internet, that will be happen through the internet gateway. The name itself says that internet gateway. Okay, gateway means the entry and exit point. Okay, you know about that, right? So every time whenever some people has to enter into your home, they have to enter through the gate itself. If they have to go outside of your home, they have to exit from the gate itself. So now what is meant by internet gateway? Any traffic that is coming from the internet, or else any traffic that is going into the internet from the VPC, that traffic will be transferred through the internet gateway only. So we need to create the internet gateway. So in which VPC we have to create that? VPC ID is equal to AWS underscore VPC dot ID. Okay. And the name of the internet gateway should be name is equal to prod hyphen IGW. Now I said you what I have said you Terraform is idempotent. Already the resources, whatever the resources are created, it is not going to create those resources again, which means duplication of resources will not be done. So now it has to create the internet gateway. Here you can see Terraform FMT, Terraform validate. Okay. Every time it is not necessary, but right now we are in the initial stages. You have to get habituated for those things. So that's why I'm giving Terraform format and Terraform validate and Terraform plan. Hmm. Already VPC is there, so it is not creating that. So it is saying that I will create only one resource that is called as internet gateway. So if you go for Terraform apply, hmm, okay. So when you specify the Terraform apply over here, then it created the internet gateway. Here you can see when I go back to the internet gateways, there you go. Prod-IGW is already created. It is created with the help of Terraform. So now the point is, whatever you are seeing here, all the values are hard coded. Whatever the values that you are seeing here in this particular configuration, all the values are hard coded. Now I don't want to hard code those values. So the code, whatever I am writing, that should be reusable. So how I can make the code reusable? So by making that variabilizing. So we want to make that code variabilize. How we can make the code variabilize? So before we go into the variabilization, do you understand the concept up to now? Any questions here? Please don't sit calmly. Please answer. Do you understand the topic?
Yeah,
Yeah, yes.
Chaitanya, one question.
Mm-hmm.
Yeah, before that user don't has that policy, right? So that time
Mm-hmm.
when we execute a Terraform plan,
Mm-hmm.
actually according to me it should fail because there is no permissions for that user, right? So it
So
won't
it is
bother
just
about
about planning, no?
no planning only, but it won't bother about access level. And I thought maybe it will go to AWS and it will check everything.
No, no, it won't be like that. It is just a planning, no? So at the time of planning, it will tell you what are the resources that are going to be created.
Yeah.
See, for
Okay. So
planning,
it won't go to AWS and it won't verify the things, correct?
yeah, correct.
Okay. So Terraform apply only where it will look for the access, everything.
Access. Yes, exactly. Whether the user is having the specific permissions or
Okay. Okay. Yeah.
not. Okay. Right, guys. Next one is where are we? Yeah. So we have to understand about variabilizing this configuration. How we can variabilize the configuration. Simple. Cider block is equal to var dot CIDR underscore block. I'll give like this. And name is var dot VPC underscore name. So var dot VPC name. And as well as here also, whatever the CIDR block is there, the CIDR block should be var dot subnet underscore one underscore CIDR underscore block. I'm going to give like this. And availability zone is equal to var dot az1. Var means variable. Okay. And the name here you can give var dot subnet underscore one underscore name. And the same configuration here also you can replicate. But before I do this, let me do one thing. I will destroy the entire configuration. Whatever the resources that we have created, we can destroy it. So let me do one thing. Terraform destroy. Terraform destroy means whatever the resources that are created by Terraform will be destroyed. Try to understand. Created by Terraform, not manually. If we created manually, so then it won't be affecting those resources. So 4 resources are destroyed. So here you can see 4 resources are destroyed. Destroyed in the sense they are deleted. Now let us do the variabilization. If you want to check out, here you can see prod internet gateway is not there, and as well as prod VPC is also not there. There you go. So we don't have the prod VPC also. That's fine. Now what we are going to do here is, let me variabilize the configuration. To variabilize that, we have to give var.vpc underscore CIDR, and simply I will provide var.vpc underscore name, and then we have to specify the CIDR block for the subnet also. var.subnet underscore one underscore CIDR, and var.az1, var.subnet underscore one underscore name. Okay, so here I can specify 2, subnet 2, az2, and subnet name 2. Okay, so if you want to specify the way, if you want to variabilize this also, var.igw underscore name. Now we have to define the variables. So right now we specified whatever the configuration is there, that is variable. So now what I have to do here is, I need to create a variables.tf, or else var.tf also you can write. Okay, so now here what you can specify is variable. Okay, what is the variable that we have given here? The variable is VPC cider. So here you can specify the VPC cider, and you can leave it, or else you can specify the default also. Default is equal to 10.100.0.0/16. If you don't specify the variable, then automatically it is going to take the default cider value. If you specify the variable, then it will take that whatever the specified value is there, that is going to be taken. So now here I have to give the description also. Description means the CIDR block of the cider block of VPC. If you want to specify the description, you can specify the description also. It is not a mandatory that you have to specify the description and default. These are the optional ones. If you don't specify also, there won't be any issue. So I'm specifying like this. Variable VPC cider, and then VPC name. This is the another variable I am defining. I'm not specifying the values here. I'm specifying the variables. I'm defining the variables. What are the different variables that are there in the code? We have to specify them. Subnet 1 cider, and then availability zone 1. Okay, and then subnet 1 name, and then subnet 2 cider, and then what else we have to specify here is we have to specify availability zone 2. Okay, AZ2 and subnet 2 name. Finally, we have only one thing that has to specify, that is internet gateway name. Okay, good. So when we specify the variables like this, then what we have to do? So let us see Terraform FMT, Terraform validate. Okay, any code error is there, it is going to validate that, and then Terraform plan. So it is asking the variables, all the variables it will ask. For example, I will give prod-igw. It will ask for AZ1, US-east-1A. us-east-1b, and CIDR value is 10.90.1.0/24. Subnet name one is somewhere like prod hyphen subnet hyphen one, and CIDR value two is 10.90.2.0/24, and subnet two name is prod hyphen subnet two, and CIDR VPC CIDR value is 10.90.0.0/16, and VPC name is prod hyphen VPC. When you give all these things on the command line, then it will create the configuration. Four resources are going to be created. But every time if I have to give like this, then that will be a very hectic situation for me. So I cannot provide like this. So in the command line, I cannot provide all the configuration. So for this, what I can do here is we are going to create a Terraform dot tf wars. Okay, so tf wars in the sense Terraform variables, and we are defining the values for these variables. Whatever the variables that we have given, we are going to specify the values. So let me copy this and alt shift, press alt shift and select all the configuration. I mean, select all the things over here, and then equal to VPC CIDR is equal to 10 dot, or else every time why we need to go for 10, 172.31.0.0, 31 or 20.0.0/16. VPC name will be prod hyphen VPC, and the subnet CIDR is, I will simply give like this, 172.25.1.0/24, and second subnet CIDR will be 2.0/24, and the availability zone is US-East-1A. Okay, and then here also US-East-1B, and the subnet name is prod-subnet-1, first subnet name, and the second subnet name is prod-subnet-2, and the internet gateway is prod-IGW. When we specify all the values over here, then what is going to happen? Let me show you. Terraform plan means it will go to the variables and it will check for the values in the Terraform TF war files. So by taking the, you don't need to specify on the command line. Simply if you specify the values in the TF war files, then directly from there it is going to take out. And for example, I don't want this Terraform. This is the default name for the TF war files. What is the default name? Terraform.tf wars. If I want to specify in this fashion, if a different name should be there, for example, dev-tf wars. So this is the name which I want to give, dev or prod-tf wars. Then here you have to specify something. If I give Terraform plan means, again it will ask me. Why? Because it doesn't know. See, Terraform doesn't know the name called as dev-dev.tf wars. It know only the default name, that is terraform.tf wars, from where it can get the values of the variables. But if the name is different, then the Terraform will not understand that dev.tf wars. We have to specify that Terraform plan war file is dev.tf wars. If we specify, then it will take the variables from the dev.tf wars and it is going to give the output in this fashion. Okay. So this is how the Terraform variables will be working. So first of all, if you want to variabilize the configurations, we have to specify var.variable name, and we have to define that variable name. Once we have defined the variable name, we have to specify the values for the variables. By default, if you don't specify the values for the variables, then where it is going to ask you, it will ask you whenever it is executing on the command line, it will ask you all the values for the variables. It is difficult for us to provide the values for the variables on the command line. What we are going to do here is we are going to create a file called as Terraform TF and inside this Terraform TF we are going to specify all the values. Whenever it is executing, whenever the Terraform is executing, it knows the default name is terraform.tf then automatically it will take the values from this Terraform TF But if you don't want the name should be like Terraform TF if you want to have a naming convention like whatever you want, so then you can specify that. So how you can specify? You can specify like prod.tf like that. But whenever you are executing the code, you have to specify the variable file name. So what is that? Prod.tf. Okay, then it will collect the variable values from that particular file and it will execute the configuration. Or else here you can specify one more thing. You can simply give like auto tf. Okay, prod.auto tf you can specify. When I go for Terraform plan, just give me a second. There will be a configuration called as auto Terraform values will be there. So from there also automatically it can take out. I will tell you in a short span of time, but give me a second. So this is how you can specify the values and you can specify the different types of files and you can specify the variables and its values. Now do you understand how to variabilize the configuration and how to provide the values for the Terraform? Any confusions here?
Yeah, can we give the values in
Hmm.
variables.tf file itself? Can't we give that? See, we declared, okay,
Hmm.
we declared, but can we assign the values here itself instead of creating other file?
You can specify the default values here. I said, default values I have specified, but var values will be provided only in the TF-var files. You asked me whether we can provide the values here itself. That is
Yes,
what
yeah,
your question, right?
correct, correct.
We can specify the default values. When I am executing that, I have given the default is equal to, I have specified the cider value here. If you remember.
Yes.
Okay, either you can give the default values over here or you can specify the values in the TF-var files. Okay.
Okay.
Hmm. So here, I don't. If you don't want to specify that, then what you can do here is auto.tf-vars also you can specify. Which means that every time you don't need to specify the hyphen hyphen var hyphen file dev dot like that. You don't need to specify. If you give auto.tf-vars, it will automatically take that. So here you can see what I have specified prod.auto.tf-vars. So you have to give the extension in this format. If you give the extension in this format, if the name of the file is different also, the default name of the file is terraform.tf-vars. That is the default name. But if you give a different name, then you have to specify the variable file. So I have given the different name called as prod.tf-vars. At that time, what I have done, I gave like this hyphen hyphen var file, which means that the values are available inside this particular file. Okay, that is what I have specified. But what you can do over here is, if you don't want to specify that var file also, you can simply give auto.tf-vars like this. So either you can give auto.tf-vars or terraform.tf-vars, or else if you don't give these two things, then you have to specify the variable file. Okay, so that is how you are going to define the values for a resources. Okay. So this is about your variable files. If you see the syllabus, I did not disclose the syllabus until now, so I just want to show you the syllabus. But before that, I hope you understand the configuration here. Now let us see the syllabus. So we have got the infrastructure as in code and then features, and we have discussed about the workflow. And then we are going to install and set up in the sense how to download the binaries and CLI basics. And we discussed about the TF files, but we did not discuss about the state file. We have to discuss about the state file, but I just gave you a glimpse of state file. State file is the heart of your Terraform, where everything will be stored inside the state file. If the state file is lost, then it will be very, very difficult for us to understand the resources which we have created. And then we discussed about the provider and resources. Data source we will discuss in the upcoming sessions. And then authentication with cloud providers, how we can authenticate with the AWS environment we have seen here. And then Terraform language, Terraform configuration syntax. We just have seen the syntax, resource and VPC, how we are going to configure variables and outputs. Outputs we'll discuss in the functions. Okay. We just now discussed about the variables. Local values we'll discuss in the functions. Conditional statements, Terraform expression. These are all the things that are going to come in the functions. And then we will be discussing about providers and provisioners. Managing state file. So managing state in the sense how we are going to store the state file, state logging, state file structure, Terraform show state. These are all the commands that we will be discussing in the upcoming topics. And remote backends, how we can store the save or else how we can save the Terraform state file. We'll discuss about that. And state import. Okay, then we will go with the Terraform modules. And then we will discuss about the advanced Terraform configuration and Terraform Cloud and Enterprise, and finally Terraform AWS environment, how we are going to work with the AWS environment. And on premises, if it is possible, I will try to show you on the VMware vSphere, VMware ESXi, how we can create the virtual missions. And then we will be discussing about the vaults and CI/CD integration. So before, once we have completed the Jenkins, then we will go with the CI/CD integration and Terraform validating and Terraform code and security and compliances, optimization, and the best practices. These are all the things that we are going to cover in this 14 days of session. So how we are going to cover that we will see here. Okay, so this is the last demo which we are going to conclude here. Demos are completed. If anyone are interested to join, you can enroll yourself for the course and you are going to learn a lot of things that I can assure you here. Okay, please try to join the course and get more and more content over the Terraform. Not only Terraform, but also Jenkins. In Jenkins, you will have so much amount of what I can say syllabus that we are going to cover, and with the help of that, we are going to make sure that everyone understand the concepts clearly. Okay, so that's about what you are going to learn in the Terraform. So, any further questions you can ask me now. Okay, any which ways, I will share the syllabus with the DurgaSoft. You can take it from there, or else you can check out in the DurgaSoft portal also. It is available over there. Okay. Any further questions? Any further confusions? If you are interested, you can enroll for the course. This is the last demo, and tomorrow onwards you will be getting a paid link. Okay, you will be getting whoever has enrolled for the course, they are going to get a paid link, and you have to join through that link. And we are having only 10 days of course left, so we need to complete as soon as possible. So get ready for the configurations. So have a nice day, and we'll meet in the next session, guys. Anything else you want to ask me, you can ask me now. Okay then. Have a nice day, and we'll meet in the next session. Bye.
Thank you.